Hi to everyone. MEM School of Engineering, Tiruchi, Department of Mechanical Engineering, online classes. Okay, subject code ME8791 Mechatronics, unit number 2. So myself, Saravanan, Assistant Professor in Mechatronics Department. This is the course objective and outcome of Mechatronics subject. So this is the syllabus. So last chapter we discussed unit number 1. So now we are going to discuss about unit number 2, microprocessor and microcontroller. In this chapter we are going to discuss about introduction of microprocessor and microcontroller, then architecture of 8085. So this is a textbook and the reference of microprocessor and microcontroller. So this is unit 2. In unit 2, we are going to discuss about microprocessor and microcontroller. Generally, we know that microprocessor is a processor which is working in a microsecond. Okay, it is a internal. It is having a internal CPU input-output module like that we have. Okay, so like that we are going to discuss. We are going to discuss in architecture of 8085, pin configuration of 8085, addressing mode, instruction set, and timing diagram of 8085, then concepts of microcontroller 8051 and block diagram of 8051. Okay, so in this chapter we are going to discuss about architecture of 8085. Okay, first we need to know, so what is microprocessor? So microprocessor is an electronic chip that function as the central processing unit of computer. For example, washing machines, microwave ovens, mobile phones it is a microprocessor. This work with the microprocessor. It is a common control. So like a computer, which is central processing unit. So it advanced application of radar, satellites, and flight communications. Okay. All processors use the basic concept of stored program execution. So program or instructions are stored sequentially in the memory. So every microprocessor has its own associated set of instructions. Instruction set for microprocessor is in two forms. One is in mnemonics, which is comparatively easy to understand, and the other is binary machine code. Okay, so this is the basic diagram of Intel microprocessor. Okay, that is first in microprocessor was invented by the Intel. That is 8085 Intel IC. Okay, Intel 8085 is an 8-bit microprocessor which is introduced in 1977. So the 8085 is a conventional non-Neumann design based on the Intel 8080. So it is designed by using NMOS technology. So the 5 in the model number came from the fact that 8085 requires only the 5 volt. Okay, that 8 represent the 8 bit of data bus. So that is 5 represent the only 5 volt power supply. It is required. So rather than the require of plus 5 volt, minus 5 volt and plus 12 volt, the 8080 needed. It has 8 bit data bus and 16 bit address bus. It can work up to 5 megahertz frequency. So it has 40 pins in its chip. Low order address bus is multiplexed with the data bus to minimize the chip size. 8085 has extension to support new interrupts with 3 maskable interrupts, RST 7.5, RST 6.5 and RST 5.5. One non-maskable interrupt, that is trap, and one external service interrupt, INTR. The RST N.5 interrupts refer to actually pin on the processor, a feature which permitted simple system to avoid the cost of a separate interrupt controller. So basic features of 8085. So 8085 is a single chip 808-bit microprocessor. 8085 microprocessor provides on chip clock generator, one accumulator, one flag register, 6 general purpose register, and 2 special purpose register, and 8-bit ALU, that is arithmetic logic unit, 8-bit internal data bus, 8-bit accumulator, 16-bit program counter, 16-bit data, 16-bit stack pointer, requires a plus 5 volt DC power supply, 16 address lines. It can access 64 kilobytes of memory. It can run at maximum frequency of 3 megahertz. Maximum frequency of 3 megahertz. So features of 8085, it is a single chip NMOS device with 40 pins. It has multiplexed address on the data bus AD0 to AD7. It works on 5 volt DC power supply. The maximum clock frequency is 3 MHz while minimum frequency is 500 kHz. It provides 74 instructions with 5 different addressing modes. Okay, this is the complete structure of architecture of 8085. Okay, in this unit, in this architecture, we have multiple number of functional units. Okay, like ALU and instruction unit, then register unit, then address bus unit, then serial input output control, then interrupt output control, then timing and control unit. Okay, these are the different functional units available in the 8085 architecture. Okay, these are the internal 8-bit bus, which is carry the address and the data. Okay, so already we know that 8-bit data bus and 16-bit address bus. In 16-bit address bus, lower bytes, that is AD0 to AD7 are multiplexed. Okay, when given to the some process, it will be demultiplexed with the ALE instruction, address latch enable instructions. Okay, let's see one by one. Okay, so operation of 8085. So it is performed 4 different operations: memory read, memory write, input output read, and input output write. So memory read means internal read and internal write. That is, if you are going to access the small memory, so like program memory, like data memory, we need to use memory read and write. So if you are accessing the external device like stepper motor, switch, LED like that, we need to use input output read and input output write. So for communication, for accessing the data, for read and write process, we need to know the carriers, because we cannot send the data with the open place. Okay, we need to send with the some particular bus. So bus is a collection of wires. It is a parallel communication. It is working a parallel communication concept. Here we are using 3 type of buses. One is address bus, another one is data bus, another one is control bus. So address bus carrying the uh, address values. That is, we have 16-bit address values. Okay, so that is carrying by the address bus. Then data bus, we have 8-bit bus. So mostly it is mixed with the address lower bit. Then control bus, it is a single bit bus. Okay, so for read and write operation enable, for status operations enable like that, status register like that enabled by the control bus signals. So this is the architecture of control bus, overall bus architecture. So this is the control bus. So control bus also having like that other buses, but it have all the lines are used for a different kind of controlling operations. Okay, so this is the data bus. So data bus, then address bus. Okay, generally address bus will given to the external to the memory. Okay, that means we are sending the microprocessor to address bus. It is a unidirectional bus. Control bus and data bus will be bidirectional bus. So only it is mentioned by the both directional. Okay, for address bus it is a single directional, will be given by microprocessor to the memory. So it is a unidirectional bus. So arithmetic logic unit, it is consists of accumulator, temporal register, flag register, and arithmetic logic unit. It is a 8-bit operation of arithmetic and logic functions. Arithmetic like addition, subtraction, multiplication, division. So like that. Logical operation like undo or not, XOR, XOR, like that we can define. We can calculate. Like that we are using the arithmetic logic unit. So here we have special register, that is accumulator. Okay, why we are called as a special register means, that is, if you are adding, if you are subtracting, If you are performing some logical operation, means any one of the input will be any one of the input should be stored in accumulator. Okay, because we can multiply with the data with the accumulator only. Okay, if you are going for multiply 5 with the 4 means, so any one of the data 4 or 5 should be 4 or 5 should be in the accumulator. That is the concept, basic concept in the accumulator concept. So we called as accumulator as a special register. So temporary register sometimes used for the external accessing, then stack pointer operation, like that they are using temporary register. So flag register, we have 6 types of flag registers, that is show the status of arithmetic and logic unit. So like that, if both the data are same, output will be 0. So some flag will be enabled. So that means some flags will be one change the state. Like that we can know the status of arithmetic logic unit. So this is the AL unit accumulator. So temporary register. So flag flip flops. Okay, that is 1-bit storage device. Okay, then arithmetic unit output to the internal data bus. Okay, already we discussed sequence of operations. One operand is in the A register, that is already discussed. The other operand may be in the general purpose register or memory location, which will be transferred to the temporary register. Contents of the accumulator and the temporary registers are considered as the input of ALU. The results of ALU operations is transferred in the A register through internal data bus. Okay, so the content of the flag register change depending on the result. Okay. These are the operations performed by the ALU: addition, subtraction, logical and logical or logical XOR, complement, increment by 1, increment, decrement by 1, rotate left, rotate right, and clear. Okay, in this we didn't see the multiplication and division. Okay, in 805 we don't have multiplication and division performance. So multiplication done by the repetitive addition process. For example, if you are going to multiply 5 with the 6 means we need to add 5 with 6 times. Okay, by repetitive addition method we can calculate the multiplication of two numbers. For division, by subtracting repetitive. Okay, for example, if you are going to subtract 4 by 2 means you have to subtract with 4, subtract 4 with minus 2. Okay, so how many times we are subtracting the value up to the output value will be 0. This is the repetitive subtraction process for the division. Okay, so timing and control unit, this is the main control unit of the microprocessor. So control unit control the operation of different unit while the CPU generate the time sequence signals for execution of instructions. The unit control the data flow between CPU to memory and CPU to peripheral devices. It controls the entire operation of microprocessor. The timing and control unit act as the brain of the microprocessor. So we have different kind of registers. It has 6 general purpose registers: BC, DE, H and L. So 2 registers combined form register pair and stored 16-bit data. That is, if you want to add 2 16-bit means we can use the 2 8-bit register as a combined register, like that: BC, DE and HL. Okay, accumulator, flag register. Okay, so there are 2 more 16-bit register. One is stack pointer, another one is program counter. So stack pointer used for the memory jump and operations, like that we can use. Okay, program counter, which is store the address of the next instruction. It is store the address of next instruction, which is going to execute. Which is going to execute. This is the concept. Then instruction register. Then program status for we get. Okay. Special purpose registers, program counter, stack pointer, flag status register, instruction register, memory address registers, then temporary register. These are the special purpose registers. So program counter, it is a 16-bit special purpose register. It holds the memory address of the next instruction. It holds the memory instruction of the next instruction which will be executed. So this register keep track of memory location of the instruction during the execution of program. So microprocessor increment the program counter after execution of each instruction. This is the operation of PC. So stack pointer, it is a 16-bit special purpose register. The stack is a sequence of memory location in the read-write memory. So starting of the stack is defined by the 16-bit address into the stack pointer. So programmers use this register to store or retrieve the content of the accumulator. So flag register program counter during execution of programs. So ALU includes 5 flips which are set or reset after an ALU operation. According to the content of accumulator and other general purpose register like that. So status of each flip-flop known as flag. There are 5 flags: carry flag, parity flag, auxiliary carry flag, zero flag, and sign flag. Okay, this is the construction of a flag register. Sign flag Z, that is zero flag, AC auxiliary carry, P for parity, C for carry flag. Carry flag. So arithmetic operations generate the carry in case of addition or borrow in case of subtraction means after execution carry flag is set to 1. So position of the carry flag is D0. So after arithmetic or logical operation, if number of ones in the result is even, then it is parity, then parity flag is to 1. If number of ones in the result is odd, then it is odd parity, then parity flag set to 0. So position of the parity flag is D2. In arithmetic operation, if carry generated by the bit D3 and passed on D4, then auxiliary carry flag will be set. Zero flag. When 8-bit ALU operation result is 0, then zero flag will be set. So this flag affected by the accumulator and the general purpose register. So position of the flag register is D6. So sign flag as important only on signed arithmetic operations. So MSB of the 8-bit is the sign bit. So when the number is negative, it is 1. When number is positive, it is 0. So program status bar. So in your flag register 5 bits D0, D2, D4, D6, D7 indicate the status, and 3 bits D5, D3 is undefined. So next instruction register. The instruction register holds the operation code, that is opcode of the current instruction of the program during arithmetic and logical operation. The instruction is fetched from the memory prior to execution. So the decoder takes the instruction and decodes. So after that, decoded instruction pass to the next stage for execution. Next, memory address register holds the address of the next program instruction. Then MER feeds the address bus with the addresses of the memory location of the program instruction which will be executed. So temporary register, it is 8-bit register associated with the ALU. So this register holds data during arithmetic and logical operation. So there is this register used by the microprocessor but is not accessible by the programmer. So already we discussed with the address bus and data bus like that. So data bus, it is used to move or transfer data in binary form. So data size of the data bus is 8-bit. The data bus consists of 8 wires, hence 2^8 combination of binary digits are possible. So this bus is bidirectional bus. this bus coordinating. So control bus, this bus coordinating and controlling microprocessor operations. So read write line is a control signal. So read is equal to 0. That is active low condition. That means they are putting bar in the above RD. So that is active low condition. When is 0, it will work on the right condition. Okay, if RD is equal to 0, memory and other input output devices are read. When WR is equal to 0, data can be written in memory and any other devices. Okay, these are the status signal S0, S1, input output memory read, write, ALE, ready, hold, and HLDA. So this is the status of 8085. So it is controlled by the I0M, sorry, IOM, S1 and S0. So IOM, if it is 0 means it is select the memory. If it is 1 means it is select the input output devices. Okay, like that we can define this read and write operations. That is memory write, memory read, input output read, and the input output write. So finally we have 0 and 1 means it is a opcode fetch, because most of the all the opcodes are stored in the memory. So only we are selecting the memory in the opcode fetch. Okay, this is the status code and the status of 8085. So that is 111 condition means it is a interrupt acknowledgement. If 00 means it is a halt. If all the values are don't care condition means it hold or reset condition. Okay, this is the architecture of 8085. So I think we discussed all the functional blocks of 8085 microprocessor. It is one of the basic processor by designing in the CPU, which is used in the different applications like that in the manufacturing field, like that satellites. So in the communication field also, then microwave, AC, like that they are using. It is the complete structure of 8085 architecture. I hope you all know very well about the 8085 architecture. Okay. Okay, thank you. We will see in the next class.